Hello everyone. Let's get started with the video. Today's topic is resistance of a system of resistors. So in the previous video, we have discussed about Ohm's law. We have seen the mathematical expression of it, and we have seen that there is a constant which is present in the Ohm's law, which is called the resistance. Today, we will look into the different combination of resistors which we need in order to study a complicated circuit or a simple circuit. So the first topic will be the introduction for the resistors. So basically, what are resistors? Resistors are basically those circuit components which can reduce the flow and lower the voltage levels within the circuit. Now you can use single resistor or a multiple resistors depending on our requirement. Okay, so whenever we are using multiple resistors, in that case we have to use combination of the resistors. Now, there are two simple combination of resistors that we are going to study in this chapter. First is series and another one is parallel. Okay, so now let's understand what are the different circuit components, because without understanding the circuit components, you cannot actually understand the circuit diagram. Okay, so this is a simple circuit diagram as you can see in the right hand side figure. So there is a light bulb, there is a switch, there is a resistor. So here a single resistor has been connected. This is a battery. So battery is a combination of one or two cells or three cells. So here basically what is happening, this battery is going to provide the source to the complete circuit. Okay, this is the wire which is connecting all of the circuit components. Okay, now the wire has to be a conducting wire. Now this is a switch which can break or make the circuit. So this is the resistor as we have discussed right now. And this is the light bulb which is basically a load. Okay, so here light bulb is doing what? It is basically consuming the electrical energy from the circuit and it is giving off light and heat. So this is basically kind of output. So if we connect properly, actually, this light bulb is going to glow. If it does not glow, that means the circuit must not have any kind of conductor. Okay, that's why the glowing will have any kind of problem in the glowing of the light bulb. So now this is a single resistor which has been connected. Now let us see when we connect multiple resistor, what happens. So the first combination that we see, that is the resistors in series. Now you can see the right hand side figure. We have first resistor, second resistor, and this is the nth number of resistor. So here we have given a dot 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 in this circuit. This implies it's a continuation basically. Okay, so this implies that there can be a number of resistors. Okay, n is the number of resistor. So n number of resistors can be connected in the circuit. Now, what is the importance of these kind of circuits? As you can see in the circuit diagram very carefully, that all the resistors are connected back to back. Okay, so they are basically connected back to back in the circuit. And if here I is the current which is flowing through R1 resistor, it will also flow through R2, it will also flow through the nth number of resistor. So all of the resistors will have the same amount of current flowing through it. Okay, but the voltage basically here, the voltage will be different. So it will be V1, V2, and for this it can be Vn. Okay, but there is a major disadvantage in this kind of circuit. So basically what happens, suppose if one of the resistor is not working. Okay, so what we have to do, we have to turn off the entire circuit and then we have to remove that faulty one and then we have to replace it and then it will work. So if one of the appliances is not working in these kind of circuit, it is going to damage the entire circuit. So this is the major disadvantage of this kind of circuit. Now, suppose there are multiple resistors which are connected, suppose 2 resistor or 3 resistor. So I need to find the equivalent resistance of this kind of circuits. How will I do that? So let us do a simple derivation. As you can see in this figure as I have given here, so there are 1 resistor, 2 resistor and 3 resistors which are connected in series because they are connected back to back. Here there is a voltmeter which is connected in parallel to the circuit, and here there is an ammeter which is connected in the series. There is a battery, there is a key, this is the current which is flowing through the circuit, I. Now as we have studied that the voltage across each of the resistors will be different. Suppose this is V1, this is V2 and this is V3. So my total voltage will be divided into V1 plus V2 plus V3. Okay. Now from Ohm's law, we know that V is equal to IR. We have studied that in the previous video. So V1 can be written as IR1, V2 can be written as IR2, and V3 can be written as IR3. Okay. So if I consider R is to be the equivalent resistance of this circuit, so I can substitute everything in this formula. So I can write here IRS is equal to IR1 plus IR2 plus IR3. So I'll take I common, that is R1 plus R2 plus R3. So IRS is equal to this. So I'll cancel II. So I'll get RS is equal to R1 plus R2 plus R3. So from this formula, we can understand that the equivalent resistance in case of a series circuit is nothing but the combination of the algebraic addition of the individual resistances, right? Now, in this case, we can also understand one more thing, that the current is the same in all the resistors. However, the equivalent resistance in any series circuit is going to be more compared to that of the individual resistors. So if the resistance is more, then obviously the current flow will be less. That is what we have studied before, right? Because resistors are basically used to control the flow of current. So if the resistor value, the equivalent resistance is high, which is going to be in this case of a series circuit, then the current in these circuits will be very low. Okay. Now, one more thing we will look into it, that is a special case. Suppose my resistors are basically not different. They are equal to R. All of them are equal resistors. Okay. Now, there are n number of resistors. So now how will I write the equivalent resistors? So I can write RS as R plus R plus R, because I don't know, n number of resistors are there. So I can write it as NR. So RS is equal to NR. So please be careful, because this formula is only applicable when you have equal resistors. When you have unequal resistors, you have to go with the previous formula. Now, this is a very, very important topic and very, very important derivation for your boards. Please go through it once again, okay? And you have any doubt, please let me know in the comments. Thank you for listening. Thank you for your patience. Bye-bye. Take care.